So it's really a pleasure to be here today and talk about the topic that I'm inspired by in life. For those of you that are here in the morning, you heard all about the history of the electric power system, so you realize that we are very proud about the power system. So today we will talk about future developments for sustainable energy system. So I will talk together with my colleague, Lars Nordström. We will start to talk about the visions that's driving the change. I will try to give you a short course on smart grid. Then we will give you 2 examples related to research that we do, and then a closure looking forward for the future. Starting picture is from my home library of pictures. Being a researcher, you realize quite soon that you are very lonely on your topic in your room, in your lunchroom. But you realize even faster that all your colleagues are actually all over the world. Looking back at my own history here at KTH, this is one of the highlights. This is when I had my family of friends from all over the world here visiting. And of course, it's an international conference. And this is how we work. And I'm very happy today to know that a lot of you that can't be in this specific room here can also listen and be together with us. Because I think much of the inspiring for developments is that we work together. And together we can really make a difference. So this was almost 10 years ago. And this is just a few months ago. And maybe you see 2 little characters here in the middle. And that's my little babies at home. Maybe 100 years further, we are very excited to see how the picture will look like here. And hopefully, we will still see the buildings and a lot of new systems. So, future energy system. A common combination, a concept of it, as I express it, is a smart grid. But we have to start with a vision of why we're doing this. And all over the world, we have around 10 years now, we have very high goals for changes. We call them the climate goals. Many of us started to work regarding with the Obama meeting 2008, the climate and energy emissions. So what do we want to do? Well, we want to build a lot of new electricity generation, typically from wind and solar. We want to replace the fuel, the fossil fuel. So all the different things we talk about here is driving in that direction. So what is new here? Well, the thing that's really new is actually that there's a customer that's in the middle. So the customer today can also can using the energy and can also produce electricity. And one of the big drivers here is that we actually can use new ways for transportation. And it's actually in reality that we are going back, because the first cars were actually electrical cars. So we can see in history that the technology sometimes goes back and forth. It's with the generation of hydro. We started small, we became large, and now we talk small scale again. So that is really one of the big change, is that we see the customer in the middle. When I started to work with electric power system, we didn't have customers. We had node points, load points. And this is serious. This is in 1990s. It didn't exist in the literature. You will not even find the word customer. And today that is the key. We're defining new features and functions for the customer. And those of you that listened to the previous presentation today, and I know you can read them afterwards, we're discussing a lot of different aspects here on energy storage and things. And me and Lars will talk about the power system features. So as I said, the electrical car, that is one change. The change in the electricity is one of the changes for the usage and the production. And the production is both small scale and big scale. For the wind power, for example, we can see that it's very cost efficient to have large scale offshores. But for solar, we typically see the small scale. And in a previous, the last picture from Arne Kaiser about the history, he actually showed solar on the castle, the royal castle. So maybe 100 years from now, we will see a lot of changes, and that's what we expect. So now Lars will give example on one of the research cases.
Oh, yeah, thanks. I'll skip back a few. Oh, sorry. Thanks, Lina, for painting the picture of the background. I wanted to dive straight into an example of some of the work we've been doing here at the campus, which is related to one part of this future sustainable electricity system. Up to the left here is a wind power park in some ocean somewhere. Some argue that these wind mills are not beautiful and we're putting them out in the ocean and they destroy the horizon. I would argue that among all possible ways of generating electricity, they are second most beautiful. Perhaps I think PV panels are a bit more futuristic. They have that sort of space notion. So that they're better. Then I put this, and then some at the end is a factory with a smokestack. So I'm happy with this, but what we perhaps can't be so happy with is that Mother Nature has unfortunately not located the sources of energy where we live. You know, one of the advantages of a fossil fueled electric plant is that we can place it where we want it, perhaps close to the campus here in Värtahamnen. Not nice, but very efficient. So if you let engineers decide, they place power sources close to loads. We can't do that. Nature decides that the wind is much higher out on the ocean and the sun shines closer to the equator. So for renewable sources, we get those not necessarily where the load centers are, or customers, as I should be saying, I guess. So to actually get the energy from where it is to where we need it, we need grids of various forms. And if you're old enough to remember some 100 years back, there was the war of the currents. The inventors of the AC and DC systems, when electricity was in its youth, there was a discussion whether we would be transmitting power using AC, alternating current, or DC, direct current. Direct current had all sorts of simple advantages to it. It's so much easier to know what it's doing, and it's so much easier to understand the effects of, you don't have to worry too much about the capacitive and inductive parts of the system. But unfortunately, it's difficult to transform DC to a higher voltage level, leading to higher losses in transmission. That war raged in the US, and finally it was decided, or sort of the market took over, and we built an AC system. That AC system has served us very well for quite some time, but it has some drawbacks. For instance, it's very inefficient to have long lines to the power sources out in the ocean. So therefore, we are turning more and more to DC-based system. I put up here a very busy, complicated graph to signal that we are doing complicated stuff here at KTH. It's not just colorful graphs. So there is stuff that you really need to study to understand. I wanted to show here just an example of a project we did. Several of my colleagues are working on how to build these DC grids at high voltage levels. And then we're looking at both grids that connect offshore plants, but also connect our continent so that we can transmit power more effectively across already existing AC grids. And here we're working both on the components, the actual materials that is needed to build the semiconductors, and the semiconductors need to be stacked into converters, and those converters need to be connected into grids, and those grids need to be controlled for safety and so on. This is a big part of our undertaking, and we're doing it also together with some of our strategic industry partners, and I will be name dropping then ABB as one of them, of course. But we're also looking at the control end, where we need to figure out which way is the best way to monitor and control how this grid behaves, and how do we protect it if something goes wrong. These are questions which are yet unexplored, but I'm sure 100 years from now, this is a common thing that we're building these DC grids, perhaps not only on the oceans and continent, but also perhaps in buildings where it's so much efficient in the sense that all the loads we use today, the customers, again, they're a USB level load, more or less. So why do we build all these large AC grids also in our buildings? So the future might be not just sustainable, but actually much more direct current, which simplifies all the mathematics, which then could be a hurdle for us that make a living out of complicated mathematics. So this project was really about making sure that we can have control and machines that bring the energy from the ocean to the shoreline. And this is an overall project that quite a lot of people and colleagues to us have been engaged in over the years. So Lina, time for you for another example.
Yes. So we will continue with DC. A few months ago, we were very proud to have a ceremony for the first IEEE milestone in Sweden. And it was actually DC again, because the first long-distance DC cable over sea was actually invented in Sweden around 100 years ago. So my example here is actually a result from an investigation that we did for the government to explore how different smart grid technologies could be developed at an existing grid. To make experiments in the power system is really complicated because it's a live system. Yeah? So an island is very nice because it's an isolated area. So one of the big smart grid case examples in Sweden was on this island, Gotland. Gotland was one of the first places in Sweden where we had a lot of wind power. And a few years ago, it was a big research center down here to investigate different technology of wind power. So the result that we show here is that we are investigating how it will look like if we have new possibilities for energy storage in the houses here in existing grid. And the conclusions from this bigger project is really that there are a lot of smart things we can do in an existing system that we don't need to rebuild it. We can reduce peak. We can use more transfer depending on the weather. We're showing here that when it's a colder weather, we can use the transmission more on the lines, etc. So not all of the development here needs a lot of new technology. So, Lars.
Yeah, you can. Thanks.
Yes.
Yeah. So, building on these two examples, because this is really where we are at the moment. This is technologies and methods that we're developing right now, together with our colleagues here at KTH, at other places in universities around the world, and industry partners. And with that as a base, I think we can be fairly confident that we know what will be happening the coming 5 to 10 years at least. But looking 100 years into the future, that's a slightly more challenging. And being at university, you're sometimes asked to speculate about the future. And in a way, I think it's perhaps the worst idea is to ask a scientist about the future, because to some extent, I, and I'm sure Lina and most of our colleagues, we want to be sure about things we say. We can go into speculation mode, and then we say, well, there is no evidence in any way, but I think. And that, I mean, you could ask anyone. Perhaps you shouldn't ask a scientist because we're bound a bit by, well, you know, that won't work and that's difficult and so on. But anyway, we were asked to say a few words about what we think the future would be like, and specifically then perhaps looking 100 years into the future. So we were already very sure that the future is electric. That's no doubt. I think we can agree that we see really no alternative to it. And that at least comes to me as from two perspectives. One is that the sources for renewable energy that we are inventing or rebuilding, like PV and wind and fusion, they are all related to electricity. Electricity is the form of energy that we are creating new production sources or production means for. But when you want to say something about the future, and you have this, as I have, a bit of an uneasy feeling that I should say something which is definitely true, how could I possibly say something about the future? Well, you could watch movies, for instance. There could be movies about the future. So there is one good one. Unfortunately, it didn't reach very far. It's Back to the Future. And those of you that seen the Back to the Future movie know that the future in the movie is already in the past, which is unfortunate. But if we disregard that particular aspect of that future that is in the past, one of the things from that movie was a hoverboard. Unfortunately, we people did build the hoverboard before the date in Back to the Future movie. We at KTH can in no way claim that we built it. It's I think the car manufacturer Lexus was behind. There is a cool YouTube movie about these people that ride this hoverboard across a little track. So hoverboards exist, so we have created the future that was anticipated in that movie. My point with this is that this is electric. So whatever new gadgets we come up with and whatever new features we do come up with, I bet you that 100% they will be powered by electricity and using the forces of electromagnetism in one way or the other. And that's something that the Back to the Future movie forecasted very well. We got our hoverboards and they were indeed run. There was a superconductive circuit underneath the concrete here which this hoverboard could hover through, and it was cooled. It was not, you couldn't buy it in any store, but it does exist. So we did make it, we the people. But how can we make sure that we do better than what that movie told us? How can we make sure that we really develop the future gadgets or the future solutions to the bigger problems? This is admittedly not the solution to a big problem, but it's certainly an inspiring piece of technology, what you can do with electricity. This is perhaps more along the lines of solutions to future problems. Well, I think the only thing we can do is to make sure that we have work with the smartest people. I was told by a smart person once that you should never ever hire anyone who is not smarter than yourself. Because if you set yourself as the barrier so that you don't want to hire anyone who's smarter than yourself, you're creating a quite cozy atmosphere, but you're for sure reducing the average smartness in your group. So you can never hire one who's not smarter than yourself. And the way to do that is, of course, to make sure that you hire from all walks of life and all people. KTH has not had a tremendous track record in hiring women, especially not in the electrical engineering field. And this is something that I think for all our sakes, we need to make sure that only the really smart people start working here at KTH, which I think we do, but we can only hire those that are even smarter. And then we need to turn to the women. We're really happy at the electrical engineering program here at KTH to now have close to 20% women starting in the first year bachelors, which is up from 10, which is an amazing feat thanks to inspiring work by teachers and communicators and everyone helping us to really grow the people that see that the future is electric, it's sustainable, and it's definitely something that we all need to work together to develop. Do you want to add something, Lina, here?
Perfect.
Yeah? Well, I think that with that, I'd like to conclude. I'm a bit ahead of time, but I think that's at least the main message. Or perhaps there's some questions. Yep. It is okay, so this exists. These types of farms exist. These type of grids exist in some smaller scale. There is several projects developing them. There is some land-based systems like these to interconnect grids in Asia. There is not yet a grid-like connection to these, but of course point-to-point links which bring electricity from one point into the shore. So the grids do not exist yet, but the connections do for sure.
Maybe I can give a comment there. Actually, one of the first offshore wind farms, it's actually in Sweden. It's a Lillgrund farm. And it has obviously some history of development. And you could see some challenges in the beginning on the wind farm offshore. Because, of course, it's a very tough environment on the shore with the winds and the climate and so on. So I think one of the new things here is actually that you want a meshed DC grid. So the cable itself, the DC cable, that's not new. We had that for quite long. But what's really new is that you do a mesh of it. And that's where you need new technologies, typically power electronic companies, because the DC is very hard to disconnect. That's one of the challenges with it. So the new thing is really using power electronics with technologies we didn't have before, because it's quite challenging. So again, we're going back a little bit. Lars said that they had this, we could call it the war about the DC and AC, and we can see in the future that we probably have more DC again that we had in the beginning. So it's a little bit similar, like I said, with the electrical transportation, that we're going back to some technology we had before. But it's much as a result of new material and new power electronics that we can do that. So that's part of the exciting future. 10 seconds to go. Any final comment, Lars? No. Yes. I'm very happy to answer that question. We have a lot of more electrical vehicles coming in the society. Around 10 years ago, people didn't believe that that will make a change of the system. Now we all know it will make a change of the system. So one of the change is really that when we aggregate the impact. So we actually have a new actor on the market that can be aggregation from electrical vehicles. What we can see from some of the research is that if you have an electrical car, you can actually help the grid depending on when you charge it. So even though it's not, because the price of electricity is so low, so we don't really see incentive for people to go up in the night to put on the refrigerator or something like that. But we can really see for the owner of the grid that it's really have an impact on when you charge the cars. So some of the research we do, we look at incentives and we look at different support that should be automatic typically to help people to charge the cars. So it's a really very interesting question on how we will work with EVs in the future. I think we are over time now. It's like, whoop. So nice being here. Thank you.
Thank you.